A really powerful heuristic and tool that is oftentimes used in computer science programming and the like in technology in technological areas in general. It's called a flowchart. These are really powerful. What they basically mean, they're just a graphical representation in which there's a lot of the steps, the procedures are organized in a very simple and sequential manner, and that's what makes it really great. And they integrate, combine a lot of different tools that you have been seeing. You can in fact see a flowchart in the background of this course that you can see. There's a flowchart right there. It starts with algorithms when we talked about just general algorithms and why they're powerful and what they mean, which are they're just taking an input, do some kind of rules and some modification, manipulation perhaps, and then they give you an output. And then we talk about conditionals, which can be involved in the rules, conditions based on if certain input, you get certain outputs. And then we went on to the idea of loops, which are really powerful because they make things efficient, they repeat tasks. You can combine loops and conditionals to get really powerful behavior as well. In addition to loops, you can combine relational expressions as well, which are those, and logical operators as well, because that's what you need in order to have conditionals. And you can again combine conditionals, loops. Everything is kind of related, but this flowchart really gives you a nice sequential order of how this course and how you can progress from algorithms and see what kind of different components can be integrated with algorithms to make them actually useful, and then someone can implement that algorithm in a language that a computer can understand, and then you can get really powerful behavior once you integrate that with like a physical hardware device such as Arduino, which is electronic components. So as you can see from the flowchart, there's a very sequential manner: algorithms, conditionals, conditionals to loops, loops to relational expressions to flowcharts, which are what we're talking about, and electronic components and getting the hardware piece involved. So this flowchart is really powerful. There you can combine a lot of these tools and concepts that you have been learning. Again, you can have a lot more arrows. You can have a lot more structure built into it in a customizable way, depending on your program and how your logic, which is the whole point of a lot of these concepts that we're learning, you can customize and build your own logic depending on these tools such as conditionals, loops, and stuff in a really easy graphical manner in a flowchart, which is a really powerful tool that you should do before going about either implementing an algorithm or thinking about it. Flowcharts give you a really nice graphical overview of to get from point A to point B. What do you need, and then what can if you have loops, you can have arrows that repeat back to itself, and a lot of these graphs that you end up building, in addition to flowcharts, when you're trying to implement an algorithm, are really powerful because graphical representation gives you a lot of clues and a lot of design techniques and a lot of implementation techniques that you can use to ultimately build your program up and connect it and integrate it with hardware to make a really cool and very powerful project, which is the whole point of a lot of these programming concepts. So flowcharts are really helpful and a great tool to have in your toolkit.